Hi, it's Matt, and in this video we're going to talk how to convert between a system of equations and an augmented matrix. So first off, let's talk about what a system of equations is. A system of equations will be a set of equations that involve, in general, multiple variables. And these equations can have one solution, infinite solutions, or even no solution. So an example of a system of equations is shown here. We see we have three equations, and these equations are of three variables because we have three unknowns, x, y, and z. So now let's talk about what an augmented matrix is. An augmented matrix is a tool that we use to represent a system of equations. And here's an example of it. So let's talk about what we notice. We notice that we have rows. Each row is going to represent an equation in our system of equations. Each column to the left of the vertical line will represent the coefficient of a certain variable. And then our column to the right of the vertical line will represent the constants in the equation. And that vertical line I'm referring to is the line right here. So now let's talk a little bit more about that. So how do we go from an augmented matrix to a system of equations? So the first thing we're going to do is choose what variables we would like to use. And remember that each column to the left of the vertical line, so this one, and this one, all need their own unique variable name. So I'm going to choose to use x, y, and z. X being for the first column, y being for the second, z being for the third. So now, step 2. Now that we know our variables, we want to write each coefficient to the left of the line in the first row, followed by the chosen variable with the appropriate sign. So again, right now we're just looking at our first row. I have boxed in blue. So we have a 1 here. So that 1 is our coefficient to the x. So we have 1x, then we have 3y, and then we have 1z. And since they're all positive, we're going to sum them up to get 1x plus 3y plus 1z. Now we're going to set our result from step 2, so our sum with the variables, equal to the constant to the right of the vertical line. In this case, we have 1. So this equation here, or that expression I should say, is now an equation and it equals 1. We're now going to do this for our next row, so let's repeat it for step 2 now. So we have 9, 0, 4 to the left of the line and 6 to the right. So we'll have 9x, 0y, and 4z. And then we know that that's going to equal 6. And now for our final row, which has the 5, 6, negative 9, and 2, we have 5x, 6y, negative 9z. And that's all going to equal 2, since 2 is to the right of the line. So now we have our three equations. It's now just a matter of simplifying it. So for example, 1x, we know we don't need that 1 there. We could just write x. Similarly, we have 0y. 0y is just 0, so we don't need to write that at all. So when we simplify these equations, we get x plus 3y plus z equals 1, 9x plus 4z equals 6, and 5x plus 6y minus 9z equals 2. So that's all we have to do to go from an augmented matrix to equations. Now let's go the reverse direction. So how do we go from equations to an augmented matrix? So here you see we have two equations, and our variables are x1 and x2. So step 1 will be just to set up the matrix. Remember that in our augmented matrix, we need one row for each equation. So since we have 2 rows, we know we're going to, 2 equations, we know our augmented matrix is going to need 2 rows. Similarly, we need 1 column for each variable. Again, 1 column for each variable. So we know we have x1 and x2, so we have 2 variables. So we need 2 columns to the left of the vertical line. And then, of course, we have our constants, so we need 1 column to the right side of the vertical line. So now we're going to decide which column will represent each variable. So let's choose for simplicity that x1 will be our first column and x2 will be our second column. So let's label them. Next, we now want to write the coefficients for each variable in the first equation in the first row of the augmented matrix. So here we have the coefficient of x1 will be 5. So we'll put a 5 here. Similarly, we know for x2, our coefficient is 3. So we're going to put a 3 here. And then our constant that we're setting it equal to is 8. So we'll put an 8 here. Now, let's do the second equation. So in this case, there's only 2 equations, but if there were more equations, you would just repeat this more times. But again, let's look at the second equation. We have 3x1. So the coefficient of x1 is 3. The coefficient of x2 is -9. We always want to be careful to include the sign. And then this is equal to 6, so a 6 goes to the right of the vertical line. So we get this here is our final augmented matrix, 5, 3, 8, 3, -9, 6. And just as a final note, when we write this, we don't have to write the variable names on top. You can to keep track of it, but it's not required. So now let's make a few final notes about how we go from a system of equations to an augmented matrix. So first, if a variable is not present in the equation, a 0 must be put in the augmented matrix. So for example, if we have a system with variables x, y, and z, but one of our equations is x plus 2y equals 3, we want to add a z to that equation. But we need to do it in a way that won't change the equation itself, so we add a plus 0z. 0z will always be 0, but at least now we could clearly see that the coefficient of z is 0 in the augmented matrix. So when we put this into the augmented matrix, we're going to put a 1 because that's the coefficient of x. We're going to put a 2 because that's the coefficient of y. We'll put a 0 because that's the coefficient of z, or in other words, we put a 0 because z was not in our original equation. Then, of course, we set it equal to our constant, 3, and we show that by putting a 3 to the right of the vertical line. Another note is that with all our previous steps, we noticed that all of our variables were on the left side and our constant was on the right, so we're going to want all equations to be in that form. So if we have the equation x plus 3 equals y, we want to rewrite this in the way we just discussed. So we're going to move the y to the left side and the 3 to the right to get that x plus 3 equals y is equivalent to x minus y equals -3. And now we could clearly see that the coefficient of x is 1, the coefficient of y is -1. So when we make our augmented matrix, we get 1, -1, and then that's set equal to -3. So that concludes our video. Thank you so much for watching. Feel free to leave any questions you have below. Have a good day.